units, and then you find a number of components. Well, as system integrators, we are used to integrate modules, electrolyzer modules, that they need to be inserted in racks, connected, plugged, electrically controlled. Same for fuel cells. They need a number of elements of their balance of plant. And the same is true for storage units. They are not always as simple as connect it and recharge and take hydrogen from it. But that's true also for components. As system integrators, we do not only integrate modules, we also build around them. And balance of plants need valves, sensors, they need filters. So a system integrator nowadays need to know the market, know the components, know the specific needs of the applications. So you have to know components, modules, and have a good grab on them. OK, let's move to some specific examples. So here you see a boat where, as Blue Energy, in collaboration with H2Boat, which is a spin-off of us, dealing with the integration of hydrogen technologies in the marine sector. So we integrated a fuel cell onto a boat and metal hydrate units. When you do this kind of job, you have to be aware of many things. The weight, for example. So items are heavy, can be heavy. They need to be inserted. They need to be in the right place. And so you also have to consider, how do I move this item into the right place? You have to deal with the volume. And this is something in Blue Energy we do a lot. We are very used to work in very limited spaces, as you see in another example later on. So you have to do the correct volume assessment. You have to take care of the power integrations. So how do I manage to control and power my items? And of course, since you deal with gases, you need to take good care of where pipes of vent and purges go, and you can manage them safely. So to dive more into this specific case, you can see a picture of the boat. This is currently on the sea in Liguria, Italy, north of Italy, where we are working. And you can see some pictures of the fuel cell we integrated. That's actually a Nuvera PEM fuel cell. And a shot of the module inside the boat. So our team had quite a hard work to get into tiny spaces, connecting pipes, connecting cables, and they worked with the DC-DC, the cooling, the ventilated case, control, as I discussed. But that's not only the module which needs to be integrated. That's the whole hydrogen balance which needs to be integrated on board. The classification society is always important. So safety aspects, norms and legislation should be met. In this case, we are dealing with seawater, which is quite something to be dealt with. Of course, whenever you have hydrogen, you have to deal with the ATEX compliance, and then the general aspect of the safety room, because in this case, the boat was operated by a number of people, and you had to keep them safe. Another quick word on fuel cells. Let's move to another application. That's a 20-feet container we had the opportunity to work with in the last years. Here we integrated 8 fuel cell modules. And overall, we reached a 250 kilowatt power. And in this case, the Blue Energy team dealt with the cooling, with electric, with control, as discussed before. This specific case could reach up to 17 kilograms per hour of consumption. Let's move to electrolyzers. How about integrating electrolyzers? In this case, you see the integration of Enapter electrolyzers, so AEM modules. And the customer in this case was Baglietto Yachts, so quite a big name in Italy for yachts. And they, as you can see in the picture in the bottom left, they worked with a demonstrator for their yacht applications. So they wished to bring hydrogen on board of their yachts. And in this case, Blue Energy integrated the electrolyzers. And when you purchase the module has its own certification, instructions, way of operation. But then you have to think about the rack, the whole system that you build. So you have to deal with the ATEX considerations of the rack, not the module only. So you have to deal with how to ventilate it. So make sure that you have enough space, enough safety to ventilate the modules. And this is the difference between the single module and the final product, which is the final electrolyzer. Whenever you do this, you have to deal with hydrogen leakage. You know, hydrogen is the smaller molecules on Earth. So you should use the proper fittings, the proper technology, and make sure that you are operating the best way. So work with fitting tightness and quality of materials and technology. You have to deal with the vents and the purges. Of course, the filling of the electrolyte that you need to do in the correct timing and with the correct maintenance modes, and of course of electrical connections. So we also integrated the demineralization units together with this electrolyzer to make sure that they were properly fed with demineralized water before the electrolyte solution was prepared. So let's switch to another case of electrolyzer integration. This is not really the integration of modules, but rather the integration of stacks. So in this case, we are for a customer which is named Enfos. So they work with hydrogen, but not only, also with batteries and renewables. And we are in Bruneck, in the north of Italy, where they installed an electrolyzer, which we supported in the design, integration, and assembly in the central square of the place, close to people and close to a technology park of a university, which has solar panels and use the energy to produce hydrogen and store it. So here the Blue Energy team designed how to integrate the stacks, how to safely insulate them electrically, how to deal with the hydrogen in the whole balance of plant. Of course, also, for example, dealing with the oxygen, which is found in the electrolytes, so being properly separated and safely purged, and also the purification of hydrogen. So in this case, the hydrogen was stored into metal hydrates, so the purity is really important. So as you can see by the picture, we received the stacks, we designed how to assemble the unit, and we realized a 160 kilowatt, 140 to 160 kilowatt PEM electrolyzer with a BOP in 2 meters per 1 meter. So a very, very compact application. So let's switch to the integration of metal hydrates. Yes, we discussed them before, but let's go more deeper into them. Metal hydrates allow hydrogen to be converted, chemically converted, from the gas form into the solid state, indeed metal hydrates. And to do that, you have to control the temperature and the pressure. So the thermal management is really important. When you want to store hydrogen in these units, you have to cool them down. And when you want to release hydrogen, you have to heat them up. Most times, at least in our experience, we integrate these units with fuel cells. So you can get the residual heat of fuel cell for the thermal management. But then when you work with metal hydrates, you have to deal with the state of charge. So it's not easy to get to know how much hydrogen you get inside. So you have to monitor the pressure and build a good balance of plant to understand this. And also with the weight. So the disadvantage of these units is that they are heavy, but they are beautiful for both applications. As you see, both, they need weight on their bottom. So with metal hydrates, you can do that. Of course, we discussed a defect, but the pro of these metal hydrates is safety. That's why they are great in marine and naval applications, where safety is really stressed as an aspect. And the same is for railway applications. You don't see examples today in my presentation, but we work a lot also in the integration of these units in the railway sector. Then you have to plan recharge. So you need to know how to refuel. What we do in Blue Energy as system integrators. Specifically, we go to the customer and we help you understand if hydrogen is for you, and if it's the case, which kind of technology do you need? Maybe you need some of our products. So we have an electrolyzer. Don't forget to see the electrolyzer pitch tomorrow to know more. we have metal hydrates, but then you need other technologies. We guide you to find the best technology. We help you size your hydrogen system, and we do that with softwares, such as the one you see in the screen. We build the project, so we can assemble it, and we can help you test in full with our R&D team how to operate it and how to fine-tune its operation. Then we perform maintenance services, and we guide you on how to optimally use your hydrogen technologies. The software here kicks in again to optimally get the best results out of your technologies. So to conclude, in Blue Energy, we have a workshop, we have a laboratory, and we also have a workshop of our Metidor, which is a spin-off of Blue Energy, delivering metal hydrates as hydrogen storage products. So in Blue Energy, we are a team of more than 20 people. We are based in Genoa, Italy. More than 30% of our team holds a PhD, most of them in engineering. I'm actually a chemist. We have more than 100 years of work experience specific to hydrogen. And in a small company like us, this is quite not so common, okay? And we have an average team age of less than 35 years old. So if you need support with hydrogen technologies, please call us. And visit our stand, as was said before, at D48 here. Well, thank you for your attention. It was a pleasure, and see you soon.